Hello everyone. If there is someone, I hope the stream recording will be available on YouTube soon. Now we are on LinkedIn, so everyone on LinkedIn, hello. I'm reviewing the schematic. Currently, I'm adding the net class to all three electrodes. I studied the documentation. There is an application note about the capacitive sensing by microchip, and there is an example of the PCB layout of these electrodes for capacitive sensor design for the single-ended capacitive sensor and the dual so-called conductive sensor design. So as we discussed last time, on the top layer there will be the single-ended capacitive sensor, and on the bottom layer will be this conductive sensor design, and the schematic, all the interconnection will be configurable using these three electrodes. And now I'm thinking that yes, this will be our mode. So this is the sensor, single-ended sensor, and probably I'm missing the ground part. So formally I will add this second electrode. For the simplicity, for the sake of simplicity and clearness or clarity, I will add the 0 ohm resistor between the ground node and the electrode, because otherwise the signal will be override with the ground name, or the ground name will be override with the electrode name, and this is not what I want. So let's say this way. This will be named 𝗞𝗶𝗖𝗱, and the net class will be electrode, and the net class will be defined in a while. I chose, according to this document, I chose the separation between electrodes of 0.5 millimeter. So this will be our clearance of this electrode net class, and the thickness of the line will be 2 millimeters. So hopefully it will work. And they use clearance equal to the thickness of the second electrode. So I'm changing my mind now. There will be two net classes, electrode and and the conductive, let's say. Yes. So this will be conductive, this one as well. So we can see we can easily change the net class in the property of the net class attribute in the field in the label properties. So now we formally have two net classes, one electrode for the single-ended capacitor sensor, and the conductive net class for the conductive sensor, the not differential pair but two-sided. So now I have to design the parameters, or enter the parameters of the net classes. As I said, the single-ended electrode net class will have clearance 0.5 5mm, and 2mm will be track width. There will be standard vias, no micro vias. We can leave it empty, and yes, hopefully it will work. Let's review the entire board setup, or maybe not review. We are working on the PCB layout. So yeah, quite too soon. The board setup has its own time. In like 30 minutes, we have to place the components. But if we have active the board setup window, we can check it. There will be 2 layers. I think it will be enough because the circuit is very similar, very simple. Sorry. Board finish will be Aniq, but just for the sake of the render. Solder max expansion 0.07. Constraints. I think just the minimum text height will be changed to 0.7. This is something I am using. 0.8 is too big, and I tested many times in the past that 0.7 is the lowest text height, that it's easy to read and it's easy to place on the board when speaking of select screen design. Tracks, yeah, I think besides of the default net class, I will use 0.3, 0.5, and maybe 1mm for something. Yeah, at least for electrodes, if there are some special needs, and 2mm as well for the electrodes. I'm not sure if the 2mm are not so thick, but we will see. We will see. In the document I mentioned in the application note, there is not discussed the same layout as they used in the datasheet of MT-CH9010, but there is something similar. And yeah, here it is. I was looking for it. So 0.5 was spacing, yes, and so this is correct. And the conductive version, yeah, I still think that the conductive version is not so different from the single-ended version. So frankly, 2mm seems too big, too wide. So I think 1mm can be fine, and conductive 0.5, 0.5. I will check. I will set this, and if the PCB layout won't work well, we can change it anyway, anytime. Okay, so here are some comments, or at least one. Good afternoon, good morning, Mahdi, probably afternoon. How are you? Thank you for watching. So, as usual, I will use the split screen mode for the component layout, because it's the easiest way for you to see me working. When I work on my designs or my customers' designs, I use 2 monitors. On one monitor there is the PCB editor, and on the second one there is the schematic editor. But now during the live stream I have only one screen, so I have to use the split screen mode. So yes, let's work on that. Yeah, you can see there are some findings by ERC. Yes, there are. The cap, Con1 and Con2 labels are not connected to anything, because there will be like custom-made electrodes, as we have discussed since the beginning of this show, of this live stream. And so this is okay. And there is another warning. The IC symbol doesn't match the library one, so I will update it now. Yeah. Of course, I added the 0 ohm resistor, so I need to annotate the schematic and call it again. Yeah. So instead of 3 electrodes, there are 4 electrodes because cap ground, as we discussed, will be grounded. And for the sake of clarity, I use the 0 ohm resistor in series of this signal to isolate it from the ground, because I don't want to mix the ground label and the electrode name label. So we are ready for the component layout. So here are our pack of components. Let's switch off the silk screen layer and the values. We don't need them. And I will hide completely this appearance panel, because in the split screen mode, every single centimeter or even millimeter is worth it. So now I will, I have to enable it again, because I have to start from some edges or from the top left corner, as I usually do. So here will be our top left corner of the PCB. The mounting hole number 1 or H1 will be placed, I think, when using the position relative tool 4.5 millimeters from this point, from the corner. Yes, this is perfect. So now I think I can hide the appearance panel and start placing components. So we have, as I can see, like 4 main groups of components. Here is the IC part. This block is the main block. So when hitting P for the pack and move footprints, I can like extract from the pack only the IC components. There is other block with the 3 position, or in fact 2 position jumpers, 3 pin jumpers. So here is our pack of jumpers. Now here is the trimmer for the threshold with some components. And here is the systemic connector to communication with the host system, like some Arduino board. So again, here is our system connector on one side of the PCB. I don't know which one, probably this one. And on this side, like going right to the right side of the PCB, there will be the electrodes. And you can see there are some components. Yeah. And I almost forgot, this block is the sleeper period setup header. We have 4 positions. Yeah, you can see I forgot to place the labels here, or at least test the description. So as I remember, we copied this from the evaluation board, but anyway, we can find the table with the parameters. So the signal is called sleeper or sleep period. So let's find the description of the sleeper period signal. Here it is, sleep period. So let's find it. Let's look for the table. Here it is. So sleep period can be configured from 1 second to 4/8, like the multiplication of 2 up to 256. And we have in our schematic, we have the voltage divider. Here is the like 0 volt. Yeah, there are like 9 100 kilo ohm resistors, and here is 1 kilo ohm. So basically this will be on 0 volt, and 0 volt is probably sleep period of one second, but I can see there is the lower limit and upper limit, and the lower limit is 1/18th of the power supply voltage. So I think we are below this limit. Let's check it. Let's check it. Yeah, we have 5 resistors of 100 kilo ohms. And yeah, I will call my favorite table, favorite spreadsheet, and you will see my thinking. Yeah, you can see my table. So we have 9 pieces of 100 kilo ohm resistor, and there is 1K on the bottom. And we need the lowest value. The lower limit is 1/18th. The VDD is 3.3. 3.3 divided by 18 is 0.183 volt. So when our maximum value is 0.183, yeah, definitely not for our voltage. So we have to make the lower resistor bigger. Let's try 10 times bigger. So, okay, we have to use this column. So we have 900,000. Here is the maximum value is 0.13. No, the lower limit. The lower limit is this one. So the voltage must be higher than this. And you can see that for 900,000, the bottom resistor must be 52K or higher, and the upper limit is 3/18th, so 1/6 of the. Yeah, but the interval is like without gaps. So okay, so we have to be somewhere above this. So when we use 56, how it works? 3.3, 56. Yes, this can be like this, but we have to check the other value. We have to check if this second position for 2 resistors is in the interval. So then we can have 256K, and the upper part will be 700. Yes, and we are at the voltage 0.88. What says the datasheet? The datasheet says that this will be ideally this ideal value is 2/9 of the voltage, VDD voltage. VDD is 3.3 divided by 9 times 2 is 0.733, and we have slightly above, but the maximum, the upper limit is 5/18. Okay, so our voltage must be lower than 3.3 divided by 18 times 5, and this value is 0.916, so we are well above. So okay, it seems that our value can work. So I will replace this resistor, 1K resistor, with 56K resistor. Yes, this will work much better and according to the datasheet. So yes, let's update the schematic. Okay, and let's pack all these components for the sleeper period. Here are our headers. I will concentrate all the configuration headers next to each other, like on the bottom, near the bottom edge of the PCB, something like this. The electrodes will be in this position somewhere here, and here is our spot for all our components. So let's do. So I will start with the IC, and we can see that the electrodes are connected to the pin number 7, 20, and 19. So these pins, 7, 20, and 19, should face the right edge of the PCB. So let's see. I set 19 and 20, 19 and 20, and 7. Yeah, luckily on the opposite side. So it seems that when we rotate the IC this way, there can be 2 electrodes for the conductive mode, and here can be 1 electrode to the single-ended mode. It can work. So our position is either this or 180 degrees rotated. I will start with this position, and we can rotate it anyway, anytime. Yeah, the second requirement, or like minor requirement, but I want it this way, is that we have all the configuration headers near in this way, near this bottom edge of the PCB. There is no edge yet, but you can imagine here will be some PCB edge. So I want there all the configuration headers and jumpers. So we have configuration ports on pin 2, 3, 4, 5, 6, 9, 10, 15, not 15 not. 15 is the 9, 10, and 15 are the interface ports, and these are interface ports as well. So here are our configuration inputs, and the pin 1 is the reset. So we are speaking about 2, 3, 4, 5, and 6, and this can work because these like 5 ports can be easily connected to the jumpers on the bottom side of the PCB. So this will be our IC position, IC rotation. So I will start with the 0 ohm resistors because there is the whole bunch of them. So again, I will use the function P, the pack and move, and start from the pin 2, which is R16, this one, we can imagine that there will be some PCB trace. So pin number 3 has this resistor. I will start placing them next to each other to save some place on the PCB, and yeah, we need always the PCB layout compact and component layout compact and like neat and tidy, because this way the PCB is small, the PCB area is small, and then the PCB cost is lower or lowest possible. Here is the resistor for pin number 5. Here for pin number 6. Pin number 7 is the single-ended electrode, and 9, 10 are the communication ports. So I will place them probably somewhere here. Yes, and I think we can go well below the level of the IC like this. And there are some other resistors, pin number 15. Pin number 15 is the systemic port, 11, 12, and 13 as well. So we can go, yeah, the question is where will be the systemic connector? Probably here, because here will be the electrodes for the liquid sensing, and here will be the systemic connector to be connected to the host controller. Okay, so we want this resistor to be about here. It's a working position, we can change it later, but I will start from here. So I can see we have a comment. Hello, the program used is KiCad. It's called KiCad. There will be the jumpers, here will be jumpers, here will be our systemic connector. So even these two resistors should be placing somewhere here. Should be placed somewhere here. And these 3 probably 2. I don't want to cross the signals, so I can imagine, yes, here is our UART enable with the resistor as well. Yes, this one. Yes, so below will be pin number 13, which is this resistor. So to avoid crossing the traces, I think we will start from the port 15 like this, then this port. Yeah, you can see it. So port number 12, this resistor, and this resistor for point number 13. No, 11. I'm sorry, 11. This resistor like this, and finally, as we said, here is our systemic connector. If there are some signals, some nets, some traces are crossed, we can always swap the signals here. It's open to be changed. So this looks promising. Here are the ESD diodes for this. We can place later. We are not in a rush with these components. Now I will focus on the decoupling capacitor for the IC near the pin 18. Pin 18 is here, so like this. The center of the pad is here, like this. Now the bunch of the reset signal components are here for passive components, all coming to the pin number 1 of the IC, which is here at the bottom, no, at the top of the, in the top left corner of the IC. So it looks like a good position as we chose. And I believe we can start from here. Capacitor for the filter. Here's a pull-up resistor like this, and the resistor from here to the tactile button. Thank you for the comment. That's this software. And the button. I believe here is the perfect spot for this button with the label, future label, like here. It can work perfectly. These components are the electrode configuration jumpers, so let's focus on these components. We have serial resistors for the single-ended sensor coming from the pin number 7. Pin number 7 is here, so I will place it here. We have some other commands. Hello. 𝗞𝗶𝗖𝗱 𝗻𝗁. I'm sorry if I'm pronouncing your name incorrectly. Very sorry. Yeah, I'm working on the, if you can see, there is the banner, the sticker on the bottom edge of the window. I'm working on the 𝗞𝗶𝗖𝗱 Liquid detector PCB layout. Last time, 2 weeks ago, we designed together the PCB, the schematic, and now I'm placing the components of the PCB layout, and then I will work on the PCB layout. So the liquid detector with microchip 𝗞𝗶𝗖𝗱 is the topic for today. And regarding this question, I want to use like a small gap in the program to promotion my courses, my tutorials on the 𝗲𝗻𝗻 platform. So if you are unsure and if you want what I do, if you like what I do and you are completely new to KiCad, I can recommend the KiCad for Beginners tutorial I made last year exclusively for 𝗲𝗻𝗻 platform. So you can visit 𝗲𝗻𝗻.com and look for KiCad for Beginners. You will find this course. If you are more skilled and if you want to move yourself to higher level, but not on a professional level, you are like the intermediate level, I can recommend my newest tutorial, KiCad for Makers, where you will design with me the embedded platform, Arduino compatible embedded platform with dual core 𝗶𝗶𝗶𝗃 Raspberry Pi microcontroller with the M2 connector for the Blues node cards, 2 power supplies, 4 power outputs, 4 analog inputs, 2 USB-C connectors, SIM card slot connector, 3 LEDs, 2 buttons. Yeah, the entire embedded platform. So another tutorial for you. You have 3 options. You can choose. Everything is written here. So go to 𝗏𝗏𝗀𝗀𝗀𝗏, KiCad for beginners if you are a beginner, KiCad for makers if you are more skilled and if you want to move yourself to the next level. Let's back to the PCB layout. So pin number 7 for the single-ended electrode. Here is the jumper isolating the output. So we need it here. And from this will be our let's say set of electrodes, or one electrode facing the very similar electrode that will be grounded. Yeah, definitely I will, but during the stream I can't comment. I don't know why, but the comments are don't allowed to be posted when I'm streaming. So please get back to my profile in an hour or so when I'm finished, and there are all links if you want to visit them now. I'm thinking how to do that. No, I can't comment, so I can create this. This is the course for beginners, the tutorial for beginners, and this one is for makers. So I know the link is quite long, but I can't comment now. Come a little bit later and everything is on my profile. If you are eager to visit the tutorial platform right now, visit my profile, open my profile, and one of the latest posts is about these tutorials. So let's get back to PCB layout. These 2 resistors are to be connected to the conductive input ports, and in fact these are pull-up resistors for pin number 19 and 20. 19 and 20 are here, and I think I will place them in this composition. I moved the coupling capacitor a little bit upward because I want the space. I want to have space for tracks here. Probably I will move the entire bunch of components a little bit lower during the PCB layout, probably like this. And 2 jumpers are here. So similarly, like the jumper for the single-ended sensor. Yeah, with a trick that I want to place this particular component 2.55 millimeters below the upper jumper to be able to use. Oh, work with me. Oh, I can see these jumpers are not matching themselves because the pin 2 is rotated, so I need to do this. Now the position reference, position relative 2 works perfectly, exactly like this. And where to place the jumpers? I think we can go here and, for instance, here. Yes, that's a requirement from the datasheet. The software is called KiCad. It's used for the entire hardware development process. So schematic editor, symbol, footprint editor, PCB layout editor, everything, KiCad. You can see here is the KiCad logo in the bottom, in the upper right corner of the window. KiCad. KiCad is the name of the tool. So we have electrode, the 0 ohm resistor isolating the ground electrode. So we can place it here, for instance, below the serial resistors for the single-ended output. And what else needs to be placed? The trimmer, the potentiometer, and all the jumpers. So let's start with the potentiometer. I think it can be placed like here, but we have to check the port. Threshold port is port number 4. From this resistor, yes, I will place it here. With a mounting hole. Like 40 millimeters below the upper one. Yes, and the potentiometer can be placed here with 2 components, the resistor and capacitor. I will place it like this. And next to the potentiometer, there will be all the jumpers. So op mode. Op mode jumper is this one. I think in the middle of the potentiometer. Yes. Op mode, the next one is sleeper period, the bigger one. So not so big one, but yeah, the bigger one, yeah, the bigger one. So I will start with the sleep period with all the resistors, and then the simple jumpers, because to place simple jumpers will be much easier. So now we have pin number 1 with this resistor from the 3.3 volt. I don't know, probably this composition. Let's start with the horizontal placement, and then we can change it to the vertical one. Yes, this looks good. And even the total height of the components plus minus match the height of the jumper, of the header, of the pin header. That's good. There is, yeah, this is the capacitor, and the bottom resistor is here. So yeah, I will use it this way. Here will be the bottom resistor of the voltage divider, and just below it, or yeah, just below it will be the capacitor. Oh, the capacitor ideally should be closer to the IC entry point, because it's the RC like low pass filter capacitor, and this is like quite long track from here to here. I can see we have some warnings. No net found for component U1/21. Okay, there is the exposed pad, and our symbol is missing exposed pad. So let's check the datasheet. Let's check the datasheet for where the exposed pad should be connecting. Connecting the exposed bottom pad to VSS is recommended. Okay, so we have to edit our symbol by adding the exposed pad electrode. Here. here, to update our symbol in the schematic and to connect it to the ground, like here, and to update the PCB. So now the pin 21 is connected to ground, yes, and warning, no net found to component R11 on pad S2, no pin S2 in the symbol. R11, where is R11? R11 is here. Oh, I can see. Our footprint contains 2 mounting holes without the direct connection. So yeah, we have to add two ports to the symbol as well. Yeah, I remember last time I deleted this section of the symbol because I didn't see the usage. So this will be the mounting pole, mounting hole position. Yes, and I will rename the port in the footprint. So MP is our number. P is our number. So instead of S1, S2, it will be called MP. MP and MP. Perfect. We have to update the footprint. We have to update the symbol. We have to connect this to the ground. Yeah, this is better. And update the PCB from the schematic now. And call the ERC. Not in the PCB layout, but in the schematic. It's too soon to check the errors in the PCB layout because it's full of errors because the PCB layout is not finished. Now, okay, and when updating the PCB, there is no founding, no errors. Perfect, we can continue. So we, yeah, I started solving issue why KiCad doesn't show me where this signal should be connected. And I think it's time to restart the PCB editor. So now it works. Okay. So let's arrange this resistor column. Yes, this can work. Here will be the pin header for the configurations. And next to that will be the op mode. The op mode jumper. The op mode jumper is this one. So yeah, we want to have these pads in line. So I will use this trick. Doesn't work because this pin header, pin 1 is on a different location than here. So we have to measure the distance manually, but it's not a big deal. 508 here. So top mode. Here will be the sleeper period. Okay, threshold is the trigger. Configuration enable. Configuration enable trigger is this one. So now we can use the position relative tool. The third will be the syslog. here.
𝗶𝗶𝗀 or follow the link in the description below.
And the third one connected with the UART. Yeah. I'm looking for the best position or better position for this, because obviously it's connected with the systemic connector. So yes, I will place it here next to the system connector. Yeah, I think this can work. The ESD diodes. Ideally should be placed in the same direction. So now with ground side facing upward. Yeah, I'm placing the diodes to be just at the level, the pad or the diode to be at the level of the pin header. I can see that our component layout is slightly moved to the bottom edge, slightly, just slightly, so something like this. I'm going to place this mounting hole to be about here, and it will be 40 millimeters far from the bottom, from the upper left corner. So 40 millimeters far from here, from this component. Yes. And finally this one, but 40 millimeters will not work for this. So it will be like here. 50, yes, 50. So 50, 50, 40 for this one, and 50 for this one. Yes. So I will modify the PCB shape, but using the 0.5 millimeter grid. So again, exactly like this. So, and here is time or space for our electrodes. So about this. I mentioned that I want to have the size of the PCB about 100 millimeter long. So here is the 100 millimeter long spot. So yes, about here. About here will be our electrodes. And the PCB width will be 90, 91, 95. Okay, I'm here in a second. So I'm back, and let's continue with the PCB layout. I will start with the electrodes because these are the most sensitive elements of the PCB. So here can be the PCB shape, but I have to be in the edge cuts layer. So let's say 13 millimeters here, 35 here. Okay, and the rough PCB is here. I will make the corners rounded, of course, and yeah, it can work. So let's work on the PCB layout. I will start with the electrodes, as I said, and we discussed that on the bottom layer there will be like the conductive sensor electrodes, the electrode composition, electrode topology, and on the top layer there will be the single-ended sensor topology. So do that this way. The datasheet says that there is recommended composition of the sensor, like here, like comp with two comps matching next to each other. So let's try, and we will find a way. You can see, let's get back to the datasheet. There are right corners. So the default setup for KiCad is 45 or 135 degrees, but we have some routing options. So when you press the command and slash on Mac, and I think control slash sign slash key on the other platforms, we can change the rounding mode to. This is the 45-degree rounded corner style. Here is the 90-degree corner style, and we will use this. And there must be some entry point to the comp, and like this, and we need the grounded one. Yes. It can work. So this looks like really good, I think. Sure, you can. If you want to repeat the design, you can. I'm working on the evaluation design, and I'm completely unsure if it will work, and if so, I can easily create a footprint for that. So if you are sure, do that. That's a good idea. Thank you for the comment. By the way, you don't like how it smoothly works using the correctly set net class in KiCad. I think that's good, isn't it? So we have our single-ended element, single-ended sensor on the top layer, and then we have to make, let's check the datasheet, the very similar structure on the bottom layer. So let's do that. But yes, this works perfectly, and definitely I will copy this setup, so I have to change the parameters of the conductive net class. So electrode is 0.5 and 1 millimeter, and clearance 0.5 and 1 millimeter track width. So let's do this. This will be our track. Our bottom track. And this one, no, I will keep it here because we need more space for the electrodes here. Here. You can see that KiCad helps me using the correctly set grid of 1/2 of the millimeter, but you have to be careful with when the route corner is placed. Sometimes, yeah, you can see now, sometimes the clearance avoid me routing, but when I start from the center of the track, it works pretty smoothly. Here. Here. So few last ones. Perfect. Let's check the PCB layout. Yes, looks good. Now, I'm not sure if the tracks are to be exposed or covered with solder mask. So we have to check this. In my opinion, probably there is a mention of this in this question, or the answer to this question in the data sheet, but I don't remember last time when I studied. I find it. Basically, the capacitive detection method can use the solder mask on the electrodes because the method is capacitive. The conductive method should use the exposed electrodes because it's conductive. The current is flowing between the electrodes. So for the conductive composition, conductive electrodes, the green ones, I will expose the PCB, and for the capacitive sensor, I will not. So it means that the green one is bottom one and the green bottom mask will be exposed. So easily done is to draw a filled zone in the bottom solder mask layer. So like here, bottom solder mask, yes. To the end of the so this is top capacitive and bottom will be exposed conductive. I think it will work. Let's continue with the tracks. So I will check the comments, no other comments, so we can work. Yeah. I'm planning to use the bottom layer for connecting the 3.3 voltage because I want these electrodes to be connected without vias, but I have to make more space. Like this. Okay, so no, do you want how I resolve this issue? I will rotate these two pull-up resistors and use two vias and connect them on the bottom layer because the jumper is obviously THD. Here. Okay. Here is the reset circuitry. 3.3 using the via as well. I want to use the thick tracks here to provide some firmness of the bottom of the button connection, even for the price that there will be some ERC or DRC findings. I'll count with it because this via is connected just on a single net, but we need it. Yes, here will be, okay, here will be the power entry point for the PCB. So I will use the bottom layer. Here and here. Okay, so the PCB, the 3.3 voltage is going from the system connector through the configuration jumper pin header. Is it okay or not? I'm thinking about that right now. No, I don't like it. I will move the jumper slightly here, or even I can rotate it. I think it's better now. Okay. I'm making some of the tracks a little bit thicker. Now these serial resistors, because majority of them, or I can see all of them, must be connected through jumpers. So I can move them here. This is much better position for the interconnection. Yeah, you can see easily to be connected. And I will use the jumpers here, like the jumper column. The last one will be a little bit shorter here.
For unlimited listening, head over to brain.fm or follow the link in the description below.
And as well here. The threshold will be connected directly. And we have to deal with the 3.3 volt. Yes. So I will use the secondary line for the 3.3 secondary trace, because we need to distribute it across the entire board. For the interconnection of these three jumpers, I will use the top layer, because at the end I will need the copper core of the reference plane on the bottom layer. And if I use the bottom layer for interconnection, the 3.3 volt, I would make the possible path for the ground like thinner. So yeah. It means that I have to focus only on 3.3 and keep in mind the return path of the ground that will be on the bottom layer, with an exception of this section. There will be no copper pore. No copper pore here, or let's say here. No copper pore. Yes. Here, no copper pore. Okay. And if we are talking about the ground plane, so I can design this polygon, thermal reliefs, okay. Below the entire PCB, and because we just defined the rule area without the copper pore will be not applied here. So this is the top layer, here is the bottom layer. Let's continue with the layout. So we need this 3.3 connection, and I will use the bottom layer again from here. but probably even like this. All here I want to have the reference plane. So I have to keep the possible pathways for the reference plane as thick as possible on the bottom layer. So this is the interconnection for the voltage divider resistors. Not slowly. So two ground vias for the bottom voltage divider resistor and the and I remember that I was speaking about the placing of this capacitor that should be placed closer to the IC. Where is the enter of the sleeper period? Here. Okay. Okay. I will place it here. Okay, I have to continue with these two vias before I route this track with another via. And I will place it here because it allows me to use it. The empty area of the PCB. Yes. So now these signals, all with vias, yes, looks good. The vias are plus minus evenly distributed, and as I said, if the traces are crossed, we can rearrange the pinout on the header, and probably we will. So ideally, this UART enable will be on pad 3. Again, UART enable is not connected to the pin header. It's only connected with the configuration header. Okay, here. Yes. This one the HB can be on the pin 3. So now, so HB on pin 3. So like this, small update. Okay. HB on pin 3, yes. So I have to rearrange this. Out is this, and yeah, this will work. And even with this drag matching the length of the other ones, definitely better. But I think I will use the shorter traces, because then I will have more area for corners here. Okay, so now focus on these lines. So there is not excessive space, so I will carefully route them here and here, and as we said, we need the polygon on the bottom side connecting the reference plane, which is ground, and ground is on the exposed pad, and we need the entry point here. So at least these traces will not cross the entry point of the exposed pad here, and here. We will use some stitching vias for the reference plane, for the ground plane, but I think if I will use this trick, we will not need them, because the entry point here for the copper is quite enough. And now these two signals, the TX and RX. Okay, TX, RX. Good. Now the top layer interconnection with slightly thicker lines, because we are connecting the pin header, and the thicker the traces are, the better, because it provides yeah, this fact provides firmness to the pin header. It's not so easy to be turned off from the PCB. Yeah. The right enable header with the 3.3 connection. Yes, and last 3 lines on the bottom side. Yeah, I want as much as copper pore on the bottom layer as possible. So yeah, but this area is not so important. So I will remove it completely and route it this way. Yes. Yes, that's good. That looks good. Even better. Perfect. Okay, so I think we have the connected board. So now we can round the corners of this. Of the PCB. Edge cuts layer. So fillet. What will be 4? 4 and 4.5. Because we placed the mounting holes 4.5 millimeter far from the corner. So yes. Okay. Okay. If the shape is rectangular, just one call for the fillet modification is needed, but it's made from the line segments, so I have to call it for each corner. Now I'm not sure if it works. Yeah, it is. It does. It works. So that's good that the fillet can be shaped in both ways, like convexually and concavely. I think I'm using the correct terms. Yeah, you can see that I don't like it and you don't like it as well. So I have to modify the shape. I have to modify the shape the way that this will be ½ millimeter. Moved, fillet, let's try it. You know what? I will use the different radius. I think 2 millimeters is fine for here, or even we can use the chamfer, not fillet. I think 2 millimeters will work pretty well. Okay. And here again 4.5 because it matches the corner of the mounting hole corner. Okay. Good. It looks well. It looks pretty well. We have to rebuild the shape, rebuild the pore. Yes. Yes. I think I will use the 45-degree corners here. Okay. Okay. And again. Okay, and I will. Yeah, it's good. It's good. Yeah, even this corner, this one. Yes. Better. Looks pretty good. Both sides. Okay, so let's work on the silk screen before we call the DRC. Why? Simply because now we should get many findings, many warnings, because the silk screen labels are like overlapping the pads, which is the manufacturing issue. But after we sort them out, there will be no issues with the overlapping silk screen layer with the pads. So it will take a while until I place all the reference designator labels. I'm removing the obvious reference designators. I don't need the reference designator for the header because I will use the labels for each header pin. I don't need designators for diodes because I don't need. I will use the designators for the resistors. Now I use the default size of the labels because there is plenty of space on the PCB. If the area is crowded with components, labels, I will use the global function. You can find here, edit text and graphic properties, and this can globally change the size of the labels. Everything is visible in my tutorials. I think in both of them. Definitely in the KiCad ForMakers. I will remove the designators for the resistors of the voltage divider because there is not enough space for them, and these designators are not important. What will be important is the description on the near the configuration header. So let's place some labels. 3.3, 3. Let's try 1 millimeter, but I think it's too big. Let's try it. Yes, it's too big and too thin. I will use 0.8, 0.8. Much better. And now I will use the trick. Create array from the selection. We have 7-pin header, and we want to copy this label next to each pad. So horizontal count will be 1, vertical will be 7, and spacing 2.54, but the source item remain in place like this. And now I only need to rename the labels. Okay, now this header, I don't know. I will use the simpler description, just the high value. And the low value. Low value and the meaning of the label or the name of the net. And this is pivot enable. I have to use like shorter version. Okay. Now here, I think we don't have enough space for the labels here. So I will move these configuration jumpers far from the big one, and we place them 508 millimeters far from this one. So now when we move them here, I think that will work much better. Yes. So here is the bottom one. Let's check the data sheet. Here, no, here. 1 second is the bottom position of the voltage divider. So 1 sec. But 0.8 is size of the label. Yes. And I will use the same trick. Yeah, the second position is 2/9 of the VCC. Two-ninths is 2 seconds. So 2 seconds. Now we have 5/9 of the seconds, 16 seconds. And the last position is 8/9 of the second, which is 128 seconds. Okay. Here. You can see there is probably a bug in KiCad. The reference designator field was still displayed even when I updated the footprint. So now these 3 configuration jumpers, I will copy this. Lower, higher position. We can copy it 3 times. Now the horizontal spacing is twice as big. Yeah. this is the same. So op mode. So figure N. Yeah, to be precise, I will use the full notation with the negation sign or line, overhead line. Top mode is here. Nice. This is threshold. The harass hold. This is reset. Sometimes I use the 𝗞𝗶𝗖𝗱 plugin for these labels, but because there is not enough space in between the jumpers, I don't want to mix them. So I will use this 𝗞𝗶𝗖𝗱 labels only for the sensor configuration jumpers. So this is conductive with like arrow at the end. Yeah, obviously much smaller version. Yes, this looks good, and this will be capacitive. Positive. The name of the PCB. Is motto 𝗞𝗶𝗖𝗱 9010 V01. Yes, and the date code. Okay, I will place it here because there is not enough space on the left side. Yeah, that works much better. How it looks here, it looks good. Okay. Okay, that's time for the DRC. No, yeah, this one. 55 warnings. It looks like a systemic error. Unconnected, and okay, this is all connected with the sensing elements. So let's focus on errors. Can't create overlaps. Okay, that's normal. That's expectable, but I placed them intentionally 2.54 millimeters far from each other to have selection to use two pin headers or 2 times 2 pin header. So that's fine. It's not an error. And this is via connected on one side only for the reset button. Okay. This is selecting overlap for the jumpers. No problem, no problem, no problem, no problem. no problem, no problem. 𝗶𝗶𝗀𝗃 overlapping as well, and unconnected ends as well. These are not applicable, these are not reasonable, because our design is correct. These findings are too general for our design. This is what I want to say. Okay. So I think it can work. It can work, and I will add the third small label with the name of the chip. Using the arrow-shaped label by 𝗶𝗶𝗀𝗃. Okay, looks good. Here is one missing label. Probably I deleted it by accident. Never mind. So the offset will be minus 2.54 from this item. Yes, 3.3 now. So UART enable, systemic connector, threshold, sleep period, operation mode, config enable, syslog. Operation mode is with or without the negation sign. Without, okay. Capacitive, conductive. Okay. Reset. I think the board is looking good, and I think we can conclude this session. So today it took 2 hours of component placement and PCB layout, but it was worth the time. The board is ready. I will keep it waiting for a few days before the final hardware review, and then I will send it for manufacturing. So thank you for watching. Thank you for being here. I hope you can benefit from my demo, from my stream, from my live stream, and see you in the next time, in the next week. And I think we can conclude the session with the information about the courses. If you are new to KiCad and want to learn more, go to 𝗏𝗏. There is one tutorial, KiCad for beginners. For absolute beginners, you will design this power supply buck converter board. If you want to move yourself to the next level, go to 𝗏𝗏 KiCad for makers. You will design this Arduino compatible embedded platform with dual core MCU and many more features. So yeah, 𝗏𝗏 KiCad for makers, 𝗏𝗏 KiCad for beginners. Thank you, and see you next week. Bye.